Hi everyone, my name is Yichi, and I'm going to share about, and my team member is Qinren, and we are going to share about our visualization final project of our U.S. County Health Data Influencing Factors dashboard. And regarding the title of the website, we have collected the U.S. County Health data from the U.S. County Health Center website, and which have multiple years data and also several different data with all the different counties in America and also for each different states. And it's an official website, so our data collection for real data is not synthetic status. So which may cause like our observation and our visualization are all based on the realistic. So let's go to talk about the data set. So our data set is they have 792 different attributes, which are all related to the health data, but we can't visualize them all. So we selected 20 different attributes here, which we may like highly focus on. And for many focus attributes, we have mainly focus on the life expectancy and the premature death, because we want to concerned about the health data, then like the death rate and the life expectancy is the most mainly focused on factors. So then we may just discuss about like how other attributes may influence this premature death or life expectancy, and then we can do some analysis. So let's go to talk about our layout of our website. So first we have our collapse US maps in the center of our dashboard. And in the left side, we have our sunburst plot. And in the left bottom, we have our word cloud plot. And in the right side of the collapse US map, we have the PCA plot. And also in the right down corner, we have our PCP plot, which shows the parallel coordinates plot. And so that's the layout of our dashboard, and I'm going to tell more in details later. Then let's move to the collapse US map. So for the collapse US map, you can select each different years by yourself, and like you can see the changes through each year. We'll also we have colored this map by each different attributes one by one, and you can select different attributes influencing factors here through the menu. And you can also see the different attributes distribution in the geomap, colorless geomap. And we have ranged the colors through their different through the domain of each attribute. So you can see the legend in the right corner. And we have made for the in terms of the user interactions, we have made the zoom in and zoom out techniques about different semantics for each layer. So first, you can select each different states in the main map, and such as we select the New York State, and you can move to the larger sides of the New York State. And once you just select a certain county, it will move to the center of your screen, and then you can like see the county's name and the number of their like certain attributes numbers. And double click will reset everything. So that's what you can do to your user interactions with all the geomap. Then that's the colorless geomap. Then let's move to the left side. So in the left upper corner, we have our sunburst, which we show in through different layers through the United States, and to different part of the United States, such as the South, such as the Northeast, such as the Midwest, such as the West. Then we have different areas, such as the mountain or Pacific areas in the west side of America, and we also have like different states, so that you can see each different states by their locations and also their different divisions in America. And also you can see we have sized those areas by their populations, because we have their populations data set attribute in our dataset. And we just color them by the selected attributes in the geomap. And then you can just see like which direction or which part of the America has the higher excessive drinking rate. And let's move to the left bottom corner. So we have made our word cloud plot. So in the word plot, it's more similar to the bar plot, which shows the top 10 or top 20 states which have the highest life expectancy. It's not only life expectancy, but the selected attributes here. And it will have different top 10 or top 20 states. And using the word cloud, you can see like those states very clearly and easily, such as you can select the Delaware states here, and then for the interaction, it can move to the states into the center of the geomap. And for some, like maybe some state size is very little, so you can very small. So it's hard for you to select in the call loss maps. So such as the DC is very small, so you can like select in the full geomap. But you can just select in the word cloud and find its place. And you can just select every state and move to it, such as the DE is maybe the highest. So you can move here and see their right number of the flu vaccinations. And you can also select others, and the word cloud may change once again. So that's our word cloud. And you may also just find that our PCA byplot and PCP byplot may just update through the geomap updating. Like once you selected one state, like all other PCP or PCA byplots, they all changed. So then let's go to move to the PCA byplot. So in the PCA byplot, we have shown our entire dataset, but it's in the high dimension. It's in the high dimensional, like 20 different attributes, and we have projected them into 2 dimensions using PCA data reduction techniques. And so in this plot, you can put your mouse over each different points, and you can see like which county it belongs to. Such as you can see some outliers, like some what's the county for those outliers number points, and you can also see the different attributes just projected into the PCA for their eigenvectors of their loadings. And you can see the main two, like the life expectancy and the premature, which we are mainly focused on. And once you mouse over some other different vectors, you can also see their names. And once you selected some attributes other than life expectancy and premature death, such as that of smoking, you can see that highlights for that attributes vectors. And then you can just observe the different angle between them and to judge their relationships. And in terms of the interaction, we have put the PCA byplot into 4 different clusters. So you can select the clusters here. Through here, we have different square for you can select different color clusters to see like which the clusters lies in the geomap. And double click can reset everything. And we have also set another interesting techniques. We call it the brush and link. So you can put your mouse from one corner and brush it into another corner, and you can see once our rectangle just wrap more points and the geomap is moving, and also the PCP is moving. So once you select the rectangle, you can also like to move its sides, or also just to move to another place and to see like what's the changes of the geomap and also the PCP. And after you select the rectangle, you can also move to another attribute, then it will maintain those points. And double click will put into everything reset. And so that's all our interactions for the PCP. And let's gonna move to the last one. So in the last we have also our parallel coordinates plots, which also shows our entire dataset in the long dimension for the different attributes. So going to show the relationship more clearly. Like you can select each different clusters here, like to see like what's the relationship between each different attributes. So for showing each different attributes order, you can just move the order by yourself flexibly, such as like this one. And we have also made a button. Sometimes you want to focus on like some certain ranges of the domain, like for the adult opacity. They may have some special meaning. And once you select the range, the PCA by plot and the geomap will also follow the updating. And by double click can reset everything. So that's all for our PCA and PCP and geomap and sunburst and our word cloud for realization and user interaction. So that's for all the realization. And we are going to, I want to still to talk more about the observation. So we have concern about the county health data, mainly about life expectancy and the premature death. So we want to know like which factors may influence them all the most. And you can see like the adult smoking and the adult obesity is high correlated with the premature death, which just is our expected originally. So regarding the slogan of bioanalytics, we had to discover unexpected and detect the expected things. So this is what our expected. And for something like we want to test the environmental factors like the water violations and air pollution, and also the flu vaccinations, you can see them all in the middle of those our mainly focus on the attributes factors. So that means like they have very, very little correlations with the premature death and the life expectancy, which means like they may be unrelated with each other. So an interesting observation is that so the highest factors which cause the highest premature death is by personal influence. It's not by the environmental influence. Like the adult smoking and the adult obesity is the personal influence factors which may cause higher premature deaths. But environmental factors like the water, like the air pollution, they don't have any influence or they don't have very clear relations between with the premature death and the life expectancy. So that's very our interesting observations. And if you want to observe more, you can just ask us and use our dashboard and do more. I'm very happy for you to use and listen to our visualization final product. Thanks.